Hello everyone. Today, let's delve into the construction of expansive soil subgrades. Do you know what is the cancer of highway engineering? When we talk about the cancer of a project, it generally refers to the problem of expansive soil in the foundation. Our country's chief expert on expansive soil engineering, academician Zheng Jianlong, has long been dedicated to the research on the treatment of expansive soil. He has turned scientific research into an interest, solving a series of major scientific and technical problems in the treatment of expansive soil in highway construction. It not only benefits engineers worldwide, but also inspires the younger generation of engineers to work hard and study diligently. Next, let's learn about the engineering properties and construction methods of expansive soil. First, let's walk into the engineering properties of it. The expansive soil shown in the diagram is mainly composed of hydrophilic montmorillonite and elite minerals, which is a type of high liquid limit clay. Its main characteristics include expansion when in contact with water and contraction when deprived of water. According to the engineering properties, it is divided into three categories: strong expansive soil, medium expansive soil, and weak expansive soil. Expansive soil has a strong potential for damaging subgrades and engineering structures. In areas with expansive soil, embankments may experience subsidence, slope collapse, shoulder collapse, and landslide deformation. Cuttings may be damaged by spalling, erosion, collapse, and landslide. Expansive soil has 6 major engineering characteristics. 1. Expansion contraction. It expands in volume when absorbing water and contracts when losing water, leading to soil cracking and potential foundation damage. This is also the most special engineering characteristic of expansive soils. 2. Multiple fissures. Due to internal and external factors such as climate, expansion contraction, and weathering, the soil has numerous primary and secondary fissures. 3. Overconsolidation. Soil layers deposited before the Pleistocene have undergone overconsolidation with small natural porosity, high density, and high initial strength. 4. Disintegration. Expansive soil expands in volume when immersed in water, making it prone to disintegration. Strong expansive soil can be completely disintegrated within a few minutes of water immersion. 5. Weathering. Sensitive to climate, it is prone to weathering damage. After subgrade excavation, the soil will quickly undergo cracking, peeling, reduced strength, and structural damage. 6. Rapid strength decay. Early strength is high, excavation is difficult, and there is a significant and rapid strength decay within a short period. Understanding the engineering properties of expansive soil is beneficial for on-site targeted treatment and selecting appropriate handling methods. Common methods for treating expansive soil include replacement, improvement, and encapsulation. 1. Replacement method. The replacement method is the simplest and most effective method for treating expansive soil subgrades. As the name suggests, it involves digging out the expansive soil, as shown in the left diagram, and replacing it with non-expansive soil or sandy gravel, as shown in the right diagram. The depth of replacement is determined by the strength of the expansive soil, local climatic characteristics, and the depth at which changes in soil moisture content due to precipitation affect the soil. The replacement method mainly considers the source and economy of replacement materials. 2. Modified method. The modified method involves adding inorganic modifiers such as lime and cement. Through physical and chemical interactions with expansive soil, the soil is modified to reduce its expansion potential and enhance strength and water stability. The diagram shows the treatment of expansive soil by adding lime. 3. Encapsulation method. For embankments with high expansivity and a lack of non-expansive soil, the geotextile encapsulation method shown in the diagram can be used. The specific construction processes are as follows. Firstly, the base of the subgrade is encapsulated to prevent capillary rise and affect the stability of the subgrade. Secondly, the entire subgrade is encapsulated to maintain the constant moisture content of the subgrade soil. Finally, the top surface of the subgrade is encapsulated to prevent rainfall from infiltrating the subgrade. When carrying out specific construction operations, we need to follow the following construction requirements. 1. Strong expansive soil has poor stability and should not be used as embankment filling material. 2. After treatment, medium expansive soil can be used as fill material for second-class and higher-class highway embankments. The total expansion contraction rate after modification should not exceed 0.7%. 3. Weak expansive soil with an expansion contraction rate not exceeding 0.7% can be directly used for filling. 4. The loose thickness of expansive soil subgrade filling should not exceed 300 mm. The particle size of soil blocks should be less than 37.5 mm. 5. When filling expansive soil embankments, timely protection should be applied to the embankment side slopes and the top surface. 6. Highways can use expansive soil with an approach to the optimal moisture content for embankment filling. However, non-expansive soil should be used as a capping layer for both sides of the embankment side slopes. The top surface of the embankments should also be covered with non-expansive soil to form core-filled embankments. For the embankments of secondary highways and above, attention shall also be paid to 1. For embankments with a height of less than 1 meter, measures such as replacement or modification should be taken according to the design requirements. 2. When the surface layer is excessively wet soil, measures such as replacement or solidification treatment should be taken according to the design requirements. 3. When the filling height is less than the total thickness of the pavement and subgrade, and the base is expansive soil, it is advisable to excavate 30 to 60 centimeters of expansive soil from the surface and replace the roadbed with non-expansive soil or treat it with lime. If it is strong expansive soil, the excavation depth should reach the depth affected by atmospheric conditions. 4. Before the construction of expansive soil embankments, experimental sections should be conducted on-site according to regulations. Attention shall also be paid to the following matters during construction of expansive soil subgrade. 1. Operations should be avoided during the raining seasons and drainage should be strengthened on-site. 2. Construction should be carried out in sections, and each process should be closely connected and completed continuously. Embankment side slopes should be trimmed according to design requirements, and protective construction should be carried out in a timely manner. 3. Where the embankment meets the cutting, a stepped method should be used for overlap, with a length not less than 2 meters. This concludes the discussion on the engineering properties and construction methods of expansive soil. That's all for today's class. Thank you.